speaker is Harry. You may recognize him from yesterday's keynote speech. We're really glad that he could take some time to be part of this session. Well known. You know, he does a little work with MPI, I hear.
Yeah.
And so he's going to talk a little bit about a monitoring tool that they have developed in their group. Thank you.
Yeah. Thank you for the kind introduction. So in the previous talks, we heard about how things aren't actually talking with each other. So for instance, your monitoring tools aren't talking with your job scheduler, they aren't talking with your MPI library, so you don't get all the information that you can potentially get. So that is exactly what we are trying to solve. How can you make all of these guys talk to each other and probably get everything under one umbrella so that you can get a holistic view of what's going on your network? And that's what we have tried to do under Aina. And I'm going to do a live demo, and we are probably going to see, if the internet holds and all, how jobs are running on our cluster back in Columbus, Ohio, which is literally halfway across the world. So the clusters and MPI are really, really complicated. So I don't have to keep saying that again. So how do you identify the interaction between these things so that you can find out which job is leading to what traffic? The typical issue that people face is, hey, my job took 10 minutes yesterday, it is taking 30 minutes now. So if these kind of questions come, how do you actually respond to your clients? Is there some historical information that you can look at as a system administrator saying, okay, let me see what happened from 10 a.m. yesterday, or let's say 10 p.m. yesterday to 10:30 p.m. yesterday on the network? How many jobs were running? Like what sort of traffic were they pumping? So can I get this sort of historical information to answer questions like this, which typically system administrators get, and as one of our previous speakers also mentioned. So several toolkits exist, but none of these toolkits actually correlate information. So you have toolkits which look at the job scheduler, you have toolkits which look at the network, you have toolkits which look at the MPI, but none of them put the information together so that you get a holistic view. And that's exactly what we are trying to do here. Can we design a tool that enables in-depth understanding of communication traffic on the network through tight integration with the MPI runtime? Now, this is broadly what we have tried to do through OSU Aina. So it's a network monitoring and analysis tool capable of analyzing the traffic on the network with inputs from the MPI runtime and the job scheduler. So this is a laundry list of features that we have. Now, having said that, let me actually go to the demo part, which hopefully will be more illuminating than me just prattling along. So this is our list of jobs that is actually running on the remote cluster right now. And this is what we are trying to visualize. So this is actually live. Let me try to refresh it so that it does come up. Delay, really can't help that. So this is like a representation. This is a logical representation of the network. So the network is actually a full fat tree with 2 levels. So this is just a logical view of the representation. This is not really how the network is laid out. So if you look at the network, it would have like 4 racks which with a lot of connectivity. But this is just a logical representation of it. Now, as you can see here, you can look at the utilization of the links by various persons. So let's say I really don't care about the links which are not that much used. So let me take that out of the picture. Now from this, I see that there are a bunch of links which are being used. Now in this image, the blue dots are the nodes and the red dots are the switches. Now let's say if you hover over a blue dot, let's pick this one. So you will realize that it is running job ID number 485100. Now what if you want to see what other nodes are using that? Okay, let me go back and see what that job ID was. 485100. Let's see. 485100. And say it's a 2-node job. So let's go back to the full network. Try to render it again. Let me hopefully pick a larger job. So, and this is why I had actually noted the numbers down before I started this. Yeah. This is one of the problems when I'm trying to do a live demo where my data source is halfway across the world. It's a little slow. So this is the other example. Now the reason why you see a bunch of links as like empty is because I have commented this out. Now let's pick this job and see what's going on with, let's say, this link. Okay. So you click on that link and let's say open link information. So if you go to that link, you would see that, hey, this link is sending some data. Now you can filter things down from the network level to maybe the job level to see what all jobs are actually using this link. Now this sort of information we get only because we are talking with the job scheduler as well as with the InfiniBand network. So without this kind of a correlation, you can't really say that this job is contributing so much data to this link. Now we can go down one level further. So again, these are the list of jobs. So let's try to see what these individual jobs are doing here. Okay. So if you go to the jobs, you would see various metrics like job level or node level CPU utilization, virtual memory utilization, and let's see, you have so many nodes which are part of this one job. Suppose you want to go into one of these nodes to see what that is doing. So let's say you go into that node and you get node level and let's say process level metrics. Now this sort of information you get because of your interacting with the job scheduler, the like Fabric as well as the MPI library. Because it is only the MPI library that can tell you that, hey, I have so many jobs running and this job is using so much virtual memory. And if you look at the communication patterns or let's say the MPI level statistics like how much internal communication buffers is it using or how much collective traffic is being sent out, what percentage of data is collectives, what percentage of data is point-to-point, what percentage of data is RMA. So for these kind of information, you need the MPI library to work. And this is basically a process communication grid. You have different kind of statistics. So you can have, for instance, job level counters. If you open the job page, if you want to drill down, if you want to have node level statistics, you can go to the node and you can have like one further level. From the node level you can go down to the process level to see how much data each process is being sent out, and there are like a lot of counters available, so you can select them. You have transmit data, receive data, collective bytes, so there are a bunch of things. So the point is that starting from the entire cluster all the way down to a single job or a single process in that job, you can drill down and figure out what exactly is happening. And this is basically because a lot of components are talking together. The job scheduler, the Fabric, and the MPI library are working together to put the data in a common place so that everything can be brought under one umbrella and shown in a like cohesive fashion. So that is the main thing that we are trying to achieve here. Now, let's go back to the link. So here we are correlating two separate pieces of information. In order to figure out what is the maximum link usage, you will have to find out how much data is actually being physically transferred over the link. You get that from the network. Now you correlate that with the job. Now how do you figure out, given a job, that two processes are going through this particular link? So you rely on the InfiniBand Fabric Manager and figure out, okay, if you have node A and node B, what is the path that like a packet from node A to node B will take through the network? Now this at this point will only work if you have static routing. Going forward, if you have dynamic routing or adaptive routing as being promised by Belnox, that is already coming. So things needs to be adapted like a little more. Now suppose you want to go from let's say a job level to a process level. So you pick a job. Now in this job, which process is contributing to the maximum traffic? Now if you look at this link, this is a bidirectional link. So you have some data going from switch A, like port A of switch A to port B of switch B, and you have data going the other way as well. Now if you see, what this clearly shows is that most of the data is going in one direction, not the other direction. So we can drill down to that level of granularity. Now, with this sort of information, you can try to figure out what sort of a job do I have. So for instance, if you have an all-to-one kind of a communication pattern or a one-to-all kind of a communication pattern, all of these things can be figured out by looking at the kind of information that we are providing. So all of this is live. Things like what I'm showing here is stuff that is currently running right now back at our cluster at Ohio State. So let me go back here. Let's say clear the selection. Go back to the full network and do a refresh. So the reason why this is taking so long is because data is actually coming in live across the Pacific from Ohio State. So it takes a little bit of time. Now if you want to say, okay, I really don't care about all of these guys. I only care about, okay. Yeah. I only care about my really heavily used links. So tell me what those heavily used links are. Now let's say, and let's look at this switch and see what's going on that one switch. Now here you can say that, hey, show me the information for the last 5 minutes, for the last 5 years, the last day, the last week, so on and so forth. I can probably pull up the information for the last 1 week, but then this is not going to show up for the next 15-20 minutes because data is streaming for the last 1 week from halfway across the world. So let's stick with the last 5 minutes and see what was happening on one of these ports. So you can see that this port was sending so much data, and you have like aggregate data and delta. So aggregate shows the amount of data that has gone historically. Delta is just showing the difference. So this kind of gives you useful information. So you see that this port has been sending a lot of data, but on the receive side, it is not getting, or the other side. So this has been like receiving a lot of data. So if you look at this is like gigabytes, and this is only megabytes. So there are like a lot of useful information like this that you can gather from such a tool. So the other thing that you can do is, because we are interacting with the job scheduler, you can see what all jobs are currently running on the system. So there is a live jobs page which says, okay, you have so many jobs running, and it summarizes things for you. So what is the average CPU utilization? So this is something that perhaps like others can use as well, to see if there are some jobs which are just stuck. So maybe it is doing I/O, maybe it is stuck somewhere. So you can figure out the average CPU utilization, what is the virtual memory, what is the total communication, the inter-node communication, the intra-node communication, and out of this inter-node and intra-node, how much was actually collectives, how much was remote memory access or MPI-3 RMA, how much was point-to-point, so like all sorts of things. And you can select various parameters here. So if you want to do like transmit data, you can like add that here. If you want to do like receive data, you can add that here. So there are like a lot of things that you can do, and there is a lot of flexibility that is being offered. So these are your typical data counters, but you can also look at error counters. So that is one of the things that sysadmins are really interested in. You really don't care if there's a lot of data happening, but you really care if there is a few errors happening. So for instance, if there is a like transmit discard. So port transmit discard or port transmit wait are two InfiniBand level counters which are indicative of congestion happening on the network. So we can show that as well here. So let's say, are there any, where is that? Port transmit discards. So as you can see, so I really don't care about the cases where you don't have any errors coming up. So yeah, this is going to take a little while. So as you can see, there are not many port transmit discards happening. So like there are all sorts of like things like this that you can do with a tool which allows you to kind of correlate information between various entities, so that you kind of get a holistic view of what is going on the network as a whole. So now having said this, let me open up the floor a little and see if there are any questions or like any concerns or any feedback. Do you think this is useful to you? What more do you think can be done? Thoughts, suggestions, comments, or do you guys want to head out for lunch? Okay.
We have never first presented.
Okay. I think I have 5 more minutes. Okay, sure. Yeah. So I just want to leave a little bit of time to make sure that we have time for some Q&A. So that's why I kind of there are like a ton more features which I can like talk about. But I just want to see if there are any questions before I go there. Yes.
One question would be: is it specific to Embed?
So there are multiple components here. You have a component which works with job scheduler. You have a component which works with the MPI library. So currently it works only with Embed 2X because that is what we do and that's what we are most familiar with. But are you familiar with this thing called the MPI-T or MPI tools interface? So the MPI tools interface is proposing what is called as an event-based like scheme. So we are planning to use that so that things can be made generic, and it will also work with other MPI libraries like OpenMPI. Now Intel MPI is something out of my hands because it's closed source, so I don't say anything for that. But OpenMPI is something that is on our radar.
The other thing is, are there any triggers?
Sorry.
So for us, we have got like 4,500 compute.
Sure.
I don't have time, quite frankly, to look at the pretty graphs.
Sure.
What I want is this code.
You want to trap our message?
Yeah, so we actually monitor these transmits and discards, and we only receive an alert if there is something there.
Sure.
So can you put all those fancy things?
Yeah. Yeah. So we have multiple components here. Like I didn't go into the like design of this thing, but we have multiple components. We have a like C daemon. We have a database so that you can have historical information, and you have a Java web server and like this web client. So the daemon can be updated to send out these messages. So like a couple of issues that we still haven't gone into is like security, authentication, and like this notification. So that was one of the main reasons why I was like why I opened up the floor for like feedback and like a Q&A, because I thought that would be like a better way instead of me prattling on about whatever we have done.
No, that is actually quite useful. So I
Sure.
see a lot of value in it.
Sure. Sure. Any other thoughts, comments? Yes.
Can you see this stuff being used to create a metric whereby feedback into the scheduler? I've seen this package before. I know it only works when it's on a tiny set of links, so most of the communication is constrained within 3 or 4 links.
Sure.
So we are going to delay your job, even though you, the user, can see lots and lots of free nodes in the system, and we're going to backfill a bit. You can take metrics out of applications like this and feed them back into the schedule.
Yes. As a user of HPC, like I would like to do it in a slightly different way. So we are working with, are you familiar with the tool called TAU? T-A-U. So like TAU is a tool from the University of Oregon. So it's a performance monitoring and analysis tool. So we are working with the TAU folks to see if we can provide feedback to the user saying that, hey, your job was using a lot of broadcast. So from the network, we see that there's an InfiniBand network and there is support for InfiniBand based hardware multicast. So why don't you try to enable this feature so that you get better performance? So we are trying to provide these kind of recommendations to the users. So the reason why we don't, let's say, modify things without telling the user is because people get pissed. So, hey, I didn't ask you to do that. Why did you do it? So we'd rather provide recommendations to users saying that, hey, try to do this, you will get better performance. And typically users are receptive that way. So that is something that we are, hopefully they're receptive that way. There are folks who never look at the output. But that's something we are trying to do, but in a slightly different way. Yes?
Another question is, I
Yes.
It's being used and people are not really accurate with using MPI. So how would you monitor this thing? Because it is going to cause depression.
So we look at the amount of like basic POSIX IO that the process has done, and that's also being sent. So that's not something that I showed, but we have a counter for that. Let me try to see if I can pull that up here. So yeah, right now I'm not able to locate it, but.
This is such a brilliant tool that if you can actually capture all the RPCs going to industrial metadata services, and
Sure.
that can actually tell you the bad behavior of the job. This is causing a lot of grief on the metadata levels. This
Okay.
becoming IO bound, so that would be another thing.
Okay. So right now we are looking at all POSIX.io, but we have not really tried to isolate like Lustre, because Lustre typically goes as IB packets. So that's something that we need to look at, but that's something that we can put on our roadmap. Sure. Thoughts, comments, questions? Yes.
Okay, sorry. So this management is based on in-band management or out-of-band?
So this is in-band. So like the C daemon actually uses the OpenSM like performance manager infrastructure to query the data. And there are like multiple things that you can do. You can either tell the daemon that, hey, I am using an MPI library that I don't support. So go ahead, query all the switches and all the like nodes. Or you can tell the daemon that I don't want you to query the nodes, just query the switches. So there's different kind of things that we do, but on the back end we are relying on the OpenSM Performance Manager infrastructure to get all this data.
Okay, so is there any way to use out-of-band? Is like some technically big problem?
So we can do that. But it would become more complex, so we'd like to keep it in band if possible. And like what we have seen is that the amount of data that we are generating really does not affect, and like I had some slides for that, but I'm not pulling it up here. But even if the MPI library is actually sending out information, it really does not affect the actual performance of the application like significantly. So you see about 1 to 2%. I think 3.5% degradation, but for the kind of information that is providing, I think that is a fair bargain. Questions, comments, thoughts? I think we have a few more minutes. So like a couple of things that I have taken note of, from the previous talk is, can we get in information about power? Or the temperature heat map. So that was another useful feedback that I got. And these are things that we can quite easily do, but just haven't like got into doing it yet or like thought about it yet. Yes.
So you have metric on the CPU usage and all that.
Yes.
And then memory density, and you have this kind of monitoring network. Can those two be correlated and flagged? A job could be flagged saying, oh, well, this job is using a lot of MPI.
Sure. So we already are summarizing this in this page, as you see. So currently, the one thing that I think as Dr. Mohammed mentioned, so one thing that we don't have is the flexibility for users to mention like events of interest. So as you said, currently we don't allow the users to say that, hey, I'm interested if like event A plus B plus C happens, and send me a note about that. So that kind of, this is like first time we are getting this kind of feedback. So this is something that we can quite easily do, because that's just a simple database query. So it's fairly, because if I can get this data, then creating a trap out of it is simple. Yeah. So yeah, it can be done.
We can take off it offline, because the idea that was coming to be, we monitor Lustre from the Lustre servers.
Sure.
All the metadata operations and OSP things.
Sure.
Possibly, you can actually spoof data per node onto this system, and we can actually correlate.
Sure. Sure.
We can actually collaborate on that part as well.
Sure, definitely. We can take it offline. Thank you. Thoughts, comments, good, bad, ugly? Lunch, maybe? Yeah, sure. Oh, okay. Thanks. Oops. So if there are no more questions, I'll I think hand over the floor to the next speaker. Thank you, guys.